Today we're going to look at similarity in right triangles. So if you have a right triangle and draw in, and this is an activity we did in class, and you can create these right triangles from a rectangle, and if you drop an altitude, which remember comes from the vertex perpendicular to the other side. So if you look at this triangle, that's a right triangle, pulled it from a rectangle there, and I drop the altitude right there, it creates these extra little triangles. All right, and these little triangles actually end up being similar. Notice that this little triangle and this little triangle both have right angles. Well, this bigger triangle had a right angle also. Okay, so that would be one angle. But then this angle 7 here is getting used in this triangle, but it also would be used in this big triangle. And remember, those would be similar by angle-angle similarity. And so we end up with, let's look. In this picture, so this is a theorem that we have, if you get yourself a right triangle and you drop the altitude, it actually creates, well, there's 3 triangles sitting there. There's this little one here, which they've drawn over here, and then there's this little one here, well, I call it the medium one, but then you have the original big triangle too. There's 3 separate triangles, and all 3 of those are similar to one another. You can see that there. So we're going to call it like there's going to be a short leg and a long leg, and there's a hypotenuse. And so those are the corresponding parts that we'll use. Looking at this, it says, what similarity statement can you write relating the 3 triangles in the diagram? Okay, so let's try this. I'm going to start off with the short leg. Well, actually, let's do this. We're going to write a similarity statement. So I'm going to write triangle. And I'm going to write, let's just start with the big triangle, which has a right angle at P. So I'm going to start with my P. And this is going to be a triangle similar to another triangle, similar to another triangle. All right? We've got to get the order right. That's what they want us to do. Make sure you get the order of your letters right. So the P is in the big triangle. Let's go to the medium triangle. This is the medium triangle right here. Which angle is the right angle? Here, it's S. Okay, and in the little triangle, which angle is the right angle? Still S. All right, so that first letter is going to represent my right angle. And so whether it's medium or small, it's still S for your right angle. Okay, the next one I'm going to do then is I'm going to get the one that's kind of like skinny and far away from the rest of the triangle. So when I look at this big triangle here, and I say skinny, I don't know, it just stretches out here farther. See how R stretches out there farther? All right. This is the skinny little angle. It's across from the short side of that, well, I should say, it's across from the short side of this big triangle here. So in the big triangle, this is my smallest angle. I'm going to go with that next. Now I'm going to go to every triangle then and pick out the smallest angle. Remember, it's going to be across from the smallest side. So let's go to our medium triangle. Okay, this is our medium triangle here. And in the medium triangle, here's the short leg. So across from that is still R. So that medium, that's R. Now let's go to the little triangle, and let's see, here's the short leg in this little triangle, and across from that would be angle P right there. So P corresponds to the smallest angle. All right, and then pretty much I'm just going to fill in the other one. This is the other angle in the triangle. So this is my, right here, this is the big triangle. So in the big triangle, I got P, R, I need a Q. So that triangle is similar to, and then I'm going to go to my medium triangle. It's an SPR. I'm missing the P. Right? And then in the little triangle, you got an S, a P, and you need a Q in that. Now what this helps us do is this helps us coordinate what sides match up, which ones are corresponding and should set up nice in a ratio. So when you look at this, this is in my big triangle, PR should correspond to the medium triangle, SR, which should correspond to the small triangle, SP. And then we can set up proportions if we have those letters in the right order. Now, that leads us to something that's kind of a cool relationship. We have something we call the geometric mean. All right, well, you're not familiar with the geometric mean, but you're familiar with the arithmetic mean. When you find an arithmetic mean, you're just going to add up all the numbers and divide by how many there are. And that's the mean or the average. That's an arithmetic mean. A geometric mean is different. The geometric mean is x for any two numbers, a and b, such that this proportion holds true. So x is your geometric mean, and you slip it into two spots on your proportion. Now I'm going to give you two numbers. They're going to go here and here. And then I'm going to put x here and here, and I can find where the geometric mean is. And it's not going to fall smack dab in the middle of a and b. Let's look at one. It says find the geometric mean of 6 and 15. So the geometric mean would have to hold true to have a 6, if I have a proportion 6 over something would equal that something to 15. That's how we set that up. And then you do your cross products. 6 times 15 is 90, and that equals x squared. And then we're going to square root both sides because we want to know what x equals. And this goes back to why we did radicals earlier. We can reduce the square root of 90 into two radicals. What's the perfect square? 9 times 10. There we go. So x would be equal to, the square root of 9 is 3, and square root of 10 stays put. Okay, see if you can do this next one. Find the geometric mean between 4 and 18. Set up your proportion and then reduce your radical if you can. I'll wait, you pause the video. Okay, here's what I got. Look, you set your proportion up where your two numbers go in these slots, your x goes in these. Ends up being a 72, which is a little bit of a tricky one. Sometimes people like to choose 9 and 8 for those factors, which works, but it's not totally reduced, so 36 is a better choice. Ends up getting you a 6 root 2. All right, now, what I'm looking for then, where we're headed with this, is I want to come up with some geometric mean proportions, where in this proportion that I would have, a particular side in one triangle is actually a different side in a different triangle. All right, so let's look at what I've got. I've suggested some things. Let's look at the short leg to the long leg. So I'm going to put short leg over long leg. But I'm going to look at the small triangle and the medium triangle. Short leg over long leg. Okay, let's start with the small triangle. The small triangle's right here. And I'm going to do short leg over long leg. All right, remember you're going to have a short leg, a long leg, and a hypotenuse. This is short leg, this is long leg. So I'm going to write A over F. Then I'm going to go to the medium triangle and do the same thing. In the medium triangle, that's this one here, the short leg is F and the long leg is B. So right there you can see what you're looking for is to have this happen, where these two values are the same. So I would say F here is the geometric mean between these two little things, A and B. Okay, let's try again. Let's do the hypotenuse compared to the short leg. And we're going to use the large triangle and the small triangle. So hypotenuse to short leg. Here we go. In the large triangle, that's the great big one, the hypotenuse is C, and the short leg in this triangle is D. So I'm going to write C over D. All right, now I'm going to go to the small triangle and do the same thing. I'm going to look for the hypotenuse. This is my small triangle. The hypotenuse is D, and the short leg is A. So I would write D over A. And again, you can see, oh, look, I've got these matching. So that means D, this right here, is the geometric mean between C and A. All right, I got one more. Well, actually, I'm going to let you do this next one. You see if you can do hypotenuse to long leg, and you're looking at the large triangle and then the medium triangle. So set up your own little proportion there. So it's going to look like this. You pick out the letters that would fit in there. Go ahead and pause the video and try that one. Here's what you should end up with here. get these matching E's. So this leg right here, this ends up being the geometric mean between this and this. Now, we've kind of gone through this, and there's probably a bunch more we could come up with, but these are 3 specific ones that we kind of use a lot to find missing values on triangles. So I'm going to take these 3 geometric mean proportions that I came up with and try to put words to them. So when you're looking at this picture here, because you're going to see this picture a bunch, you can pick out, oh, that one side is going to be a geometric mean to these other 2 sides. That's what we're shooting for. Okay, so this is the big remember slide. And I'm just going to look at those same 3 proportions. Here's what we ended up with. The altitude, which if you look at this, remember F is your altitude. You drop that down. F, the altitude is the geometric mean between the 2 hypotenuse segments. So I'm dealing with this big triangle right here. And the hypotenuse segments, well, this is the hypotenuse. It's across from this right angle up here. And it is broken up into 2 little segments, A and B. So let's write this. It says the altitude, that's F, so it goes here and here. It's the geometric mean between the 2 hypotenuse segments. That'd be little a and little b there. That's what it would look like. But of course, the letters are not going to be always set up like this. So if you can remember the words, that's almost better. The altitude is the geometric mean between these 2 little segments. That's pretty easy, don't you think? This geometric mean between those. We could do that. Okay, let's look at the next scenario. And these are kind of related, so I'm going to kind of do them as one rule. It says the leg of the big triangle is the geometric mean between the entire hypotenuse and the adjacent hypotenuse segment. Okay, that's a mess, but let's look at it. Here we go. Here's our triangle, right here. It says the leg of the big triangle. So let's say D. D is the geometric mean between the entire hypotenuse, that's C, and the adjacent hypotenuse segment. That means of A and B, it's the one that it's close to. So D is the geometric mean between the hypotenuse and the hypotenuse segment. All right, let's write that. D is my leg, so it's the geometric mean between the hypotenuse, that's C, and the adjacent hypotenuse segment, that's the little a. Okay, so that'd be one scenario. Let's try again. Let's do it with the bottom one. Only we're going to go over to the right side now. It says the leg, so the leg on this side is E, so we're going to put E as the geometric mean between the hypotenuse, that's C, and the adjacent hypotenuse segment. This time the adjacent hypotenuse segment would have to be this leg, so I'm going to put a B there. And again, I don't want to get caught up in the A, B, C's on this. Don't do that. Try to understand what the words are. Okay, now you can peek back at that previous slide if you need to, but let's go through and see if we can find some values. I'm going to look at this triangle, and every one of these is kind of the same picture. It's the right triangle with the altitude dropped. All right. We could work on Y. I'd actually do Y first probably, because remember, the altitude is the geometric mean between the hypotenuse segments. And I've got both of those. Let's set this up. So the altitude, which is Y, is your geometric mean. So let's put it in those 2 slots between your hypotenuse segments, between 3 and 9. And now we're going to solve that proportion. Do your cross products. 27 equals Y squared. Square root both sides. You have to break down the square root of 27. So I end up with Y equals 3, square root of 3. Okay, let's try again. Let's go find X. X is a leg of the big triangle. It's this leg over here. So that, remember, is the geometric mean between the hypotenuse and the adjacent hypotenuse segment. So I'm going to put X as my geometric mean. So it goes in these 2 spots, X and X, between the hypotenuse. Now the entire hypotenuse is how long? Right, it's 12. It's not part of my picture there, so you have to be a little bit careful. I have to do the math on that. And then with the hypotenuse and the adjacent hypotenuse segment. That's this one right here. That's the 9. So you're left with x squared equals 108. Square root both sides. I don't know if I've done this one. What would go into 108? 4 for sure goes in there. I could do 4. I don't know. Remember the thing, if 4 goes into it, you always want to try 16 and maybe 36. So I would check that on my calculator. And I actually, okay, so 108, let's try 36. 108 divided by 36. It does go in there 3 times. Here we go. I'm going to break that down to square root of 36 and square root of 3. So then x equals 6 root 3. All right, there we go. That's x and y. Okay, I'm running out of room. I got to write littler. Next problem. Same idea. We're going to look for x and y. I'm still going to do it with you here. I won't turn you loose yet. I'm going to start with this one here. It's just an upside down picture, but this is still the altitude. And remember that the altitude is the geometric mean between the hypotenuse segments. So let's write it. X is going to be the geometric mean between the hypotenuse segments. Well, I can see that this one is 40. What's this one? 10. That's because it's just 50 minus 40. So I've got a 10 and I've got a 40. So x squared equals 400. And you may or may not know this, but that's a perfect square. 20 squared is 400. So that one actually came out nice for us. All right, that leaves us with y. Let's see. Y is the leg, and the leg is the geometric mean between the entire hypotenuse, which is 50, and the adjacent hypotenuse segment, which is this one little right here, which we said earlier was 10. All right, y squared equals 500. That one's actually not a perfect square. I would square root both sides, but looking at what would go into it, well, 100 would for sure go into it, right? And 5 times. So y ends up being 10 square root of 5. So right here, again, this is why we did those radicals earlier, so we would be able to do these types of problems. Okay, so this one, now I'm going to turn you loose. Now I want you to try to find x and y in this picture using your geometric mean proportions. All right, pause the video, get to work. All right, there's my 2 answers. If you matched, you can keep on moving. Otherwise, I'm going to quickly run through what I did. Y is the altitude, and it is the geometric mean between the hypotenuse segments. So that's where I got that. Over here on this one, x is a leg, and the leg is the geometric mean between the entire hypotenuse, which would have to be 25, and the adjacent hypotenuse segment, which is 4. And that's where I got my numbers there. All right, here we go. This one's a little fancier. It's got some x plus 4 in there. That's kind of weird. Let's see what we can do with this. It doesn't look like I'm dealing with the altitude here. It's not marked. It's the leg. All right, so the leg is the geometric mean. So it goes in 2 slots here. Between the hypotenuse, which would be 10 plus x. I can't really add them together.